Hi folks, this is CEO speaking again. Welcome back. About a month ago, we've made a little project showing you how to measure the RPM of any of your computer fans. Now, 1 month later, we are able to pass from this to that. So we put a master in the box. So before talking about anything else, because today we're going to focus about how to make it physically, let's take a measurement. So you can hear the fan. I gave it power. And you can read now the RPM right here. Remember, you don't consider the decimal point. You put one more zero here. So the speed is approximately 4220. 4210. It has some very slight variations because by the time the bearings are warming up, the speed may have slight variations. So this is how we measure it. Now, if we stop the power, remember about the old one. And by the way, anytime the blades are moving, I can see this over my troubleshooting LED here. So telling me the sensors are working right. There are two kinds of fans in our computers. This one has 5 blades, and we may have some other ones like this one here with 7 blades. So if I just simply disconnect this one from here and from the power, and if I put it aside and connecting another one like this one here, you just have to give it power. Remember, because these are brushless DC motors, you have to consider the polarity, because inside the box of the fan there are transistors. So right now, if I give it power, this is very quiet because the speed is much lower. However, here if you take a look on the box, this is not 5 blades, this is 7 blades. So you have to put it on 7 blades. And now you can find out what is the speed is turning around, okay? So this is 1450. This is why it's so quiet, because the speed is much lower, okay? So let's talk now about the practical make of that project. When you stop the power, you're going to notice the LED. So we remove it from here. Anytime I pass my finger between the two sensors, you can see that. So that's how I can check that the pulses are sent into the box. Now, this is the most important part of the whole project, actually. I'm going to disconnect it from the power. That's a little piece of work, an artwork, if you can take a look. I had to find a situation where I can use the two sensors, unlike the two ones on the breadboard we used 1 month ago. This time the sensors, they have to remain, to stay in place, because you should be able to connect right here any kind of fan. So the biggest one I have is about this thick, and as I can enlarge this one, my clamp, to about, if we take a quick look, to about 4.5 centimeters. So it's about 1.75 inches. So this is the maximum thickness I can use for that kind of clamp. Of course, there are bigger clamps on the market. Okay, so this one I'm gonna have no problems to put it here. And this kind of clamp can easily be found. This kind of clamp can easily be found. Here is a brand new one. Okay, so if we take a look at this new one, what did I do? I just used the little pin here and the hole already inside to put my little breadboard. This is 3 by 7 centimeter. Okay, you can use 3 times 8 or 3 times 10 as you wish, because the only condition is to consider the pin right here. To consider the pin right here, which is entering my board, and the hole already there. This is going to be very sturdy. Okay. Now, how did I make the connections? If you take a closer look, here is the half of the sensor, which is the emitter, because the body is transparent. It's like a LED, but is emitting in infrared. And on the other side right here is a darker body. This is the receiver. So it's a phototransistor. It's darker again because you want to prevent the light in your environment to influence what is measuring. And they have to be just at a reasonable distance. Okay? So up to that distance is practically okay. From each of them I took 2 wires. If you can take a look, I took 2 wires. Then they come here on these connectors. This one here is the terminal block for the emitter. This one here is for the receiver. And by the way, if we take the diagram again, that was the diagram for the whole project about our counter for the RPM. And this here was the part about the sensor, only this one. This is the emitter, this is the receiver, and that's an amplifier because it has to sustain at the same time my LED for the troubleshooting and to give a signal to be measured later on. So if you put these two here aside, here is the printed board. It's 4 times bigger than the original. It's actually much bigger than the original. And I want to point you to a couple of things here because that's exactly what you see over here. What you see over here, magnified. This blue terminal block is right here. There's the anode, respectively the cathode of the infrared LED. And these are the collector and the emitter of the phototransistor right here. What is about the dotted resistor 330 ohm? Very easy to explain actually. You see here there is a 330 ohm resistor in series with the LED. And by having this one, if the power supply is 5 volt, you're going to get about 7 milliamps passing through. You may not have exactly the same kind of sensors I found. So if your sensor requires, by chance, a bigger amperage instead of 7 to have, let's say, the double of it, 14, 15 milliamps, then I provided here a place where you can mount a second 330 ohm in parallel with the first one, just in case. So you don't have to initially use it, but if your sensor needs a bigger amperage, then you can mount a second one. So 2 330 in parallel is going to make around 165 ohms. And by doing this, you increase the amperage here to 14, 15 milliamps. And here is the output of the sensor. And by the way, for the output of the sensor, you can always use a 3-wire cable. This is one for a servo motor. You can use for our Arduinos or Raspberries. This one is a bit too short. It's only about 11, 12 inches, which is 30 centimeter. You may need one about 45 because part of it is going to enter in the box. So you won't remain with much outside, but you know the principle now. A 3-wire connector. And don't be bothered by the fact that mine it has 4, because the last 2 are jumped together simply because the cable I had was recovered from a sound board of a computer, of an old computer. So I use this one, but you can use this one here where the minus is in the bottom. Okay, so you can connect it like that, so you don't use the last pin, you just don't need it. Okay, it's much easier and more elegant than mine. Okay, so this is the most important part of the whole project actually, because you have to have a reliable way to use your sensors. So by doing this, you have a loop here for the wires, so you can use it many times. And by folding these wires just a bit, they're gonna work absolutely fine, okay? So, in normal conditions, if I put these ones aside, I don't need them anymore. You can easily find them. By the way, this one is a 6 inches clamp. Okay, I put this aside. Okay, so if I just connect it back to show you how reliable it is, you always have to be careful about the polarity because you cannot connect it both ways. And I'm picking up my fan I was measuring before. The fan is over here. When you put it in the clamp, the only thing you have to take care about is that when you squeeze it in your clamp, the sensors, they have to see each other. And how do you check that? Take a look at the LED. Anytime a blade is passing through, then you see that your connection is right, okay? So if you give it power again, of course, you're gonna be able to read again the RPM for this fan, which in our situation here is about 1460 RPM, okay? So this is what you can do with the project. Roughly speaking, you just measure the RPM. Now, the project itself was designed with troubleshooting procedure in mind, just in case to make sure that everything goes right, okay? So, in order to understand what are the whistles and bells of the project, let's take a look here on one of the drawings. And by the way, I'm going to show you right away what you are going to find in the description of the video. You are going to find on Google Drive 2 folders related to the counter for the RPM. One folder is going to be the diagram, and it's going to contain 4 files inside, and one of them is, of course, the diagram you've just seen before, like this one, okay? And you're going to find the full diagram, including troubleshooting, okay, exactly as we discussed last time. And you are going to find the simplest final diagram, meaning this is the diagram with no troubleshooting elements inside, the simplest possible one, okay? But then, at the end, you are going to find a file containing the troubleshooting stages we just discussed in the previous video, okay? So I won't discuss them again. What I want to talk about anyway, I want to talk about the second folder because it wasn't there last time. It's called PCB, printed circuit board. And the first element here is this. You're going to find it in the folder. It's exactly describing what is the front of the project. And as you can see, it contains 1, 2, 3, 4, 5 elements here in the front. It doesn't show the one on the side. This one is only for calibration. I'm going to show this to you in 1 minute. But talking about these ones, you may not necessarily need this one because this one on the detailed diagram I used right here to have 3 ranges for the calibration, just in case the industrial mini voltmeter you're going to find out is not perfectly linear. So you want to split the range in 3, and for each of them to make adjustments to make sure that the indication is right, but you won't need that. Usually they're very good quality, okay? The next one here you measure the RPM, and if you put it up, this is only to test your calibration. So if I'm testing the calibration right now, what I'm going to do, I'm going to connect my generator over here, over the BNC connector. So right now, I'm not measuring the RPM anymore, so I can even stop the power to show you that. But instead, I'm measuring the frequency coming from my generator. So remember, what is the relationship between the frequency and the RPM? If the frequency is 40 Hertz, like here, to find the RPM, you have to multiply times 60 because there are 40 cycles per second, and how many you're going to have per minute? You have 60 seconds in 1 minute, so 40 times 60 is 2400. So if you take a look here, is about 2400, let's say, roughly speaking. I still have to adjust for my calibration, but just to show you the relationship between this and that. For instance, I can move on another range like this one, and it's coming very close to 2400. Okay, if I put it, for instance, to 70 hertz, 70 hertz times 60 is 4200. So the RPM, depending on what range I am, it can go up to 4200. So I still have to play a bit with the calibration to bring it 4200 exactly. It's not far, but I'm just saying, you know. And I can also bring it to 90 hertz because the speed of the fans in the computers, they rarely go above this speed. 90 hertz times 60 is 5400. So I'm not very far from 5400 here. Okay, if I'm just playing with the calibration a bit, I'm gonna go right there. Okay, so this is what you can do with the calibration. Okay, so when you remove it from here, obviously everything goes to zero because there is no signal entering inside. So if I connect back my fan, I have to put it back on measurement on the RPM. So in the moment I'm starting to turn the fan, I'm gonna be able to read something on my voltmeter. That's how it's working. Now, this one here, the second one, is not gonna be useful for the normal use, but only when you open the box to check the inside of the box. Because this is about when the counter 74193 is receiving a reset signal. If that jumper is connected to the ground, it's going to receive a signal when it's doing the whole cycle of counting from 0 to 15, so 16 positions. This is why here it says reset to 16, because the counter has 16 positions, 0 to 15. But if the jumper is put on that horizontal position here, then the signal comes for the reset from that little decoder, and that little decoder, having two options, 5 or 7 blades, is going to stop the counting at 5 or at 7. So it's important when you measure to have this reset to 5 and 7. And the next one here is about the number of blades. The number of blades we used last time was 7, but if it was the first fan I started with, which was having 5 blades, then that switch has to go up. And finally, this is not useful. This is together with the reset to 16 or 5/7. This is manual pulses. So is this stage right here. When you want to check the inside of the box, if the counter is working fine, with this one here, if I push it, it's a momentary switch. So it's coming back to the neutral. So I can use it like a push button. Instead of using a physical push button like right here, I chose to use a momentary switch just for the appearance because it looks exactly like the other ones, but the function is exactly like a push button. Okay, so by the way, this modification here comes as a version to the one I published last time 1 month ago. That's the only difference between the two schematics. Here in the original diagram, which was on the breadboard, I used a micro switch for this one. It was a little micro switch over here. You can hear it. And for the project, I used the push button. So the same number of gates had to be used. Okay, these two with a bit of different wiring, but the wiring I'm going to show you is made for this one, where I'm using a push button with the same two gates, but just wired a bit differently. So the version for the push button over here. Okay, so far so good. So now that's what you can do outside the box. Okay, so what materials do you need to make this project working? Basically, you need a box, and for the box, I can show you for the box. Let me see where it is. By the way, here is the wiring. You're going to need wiring. That's an older board, and the board size is exactly, if you take a look here, 7 by 10 centimeter. That's exactly the one fitting inside that particular box. So 7 by 10 centimeter. You're going to need 2 identical power jacks to mount on printed boards, exactly like this one. Very easy to find. That's the little price you pay for the fact that you have an industrial voltmeter. You don't have to build one yourself. You use one already made because it needs a separate power supply. But the power supplies are also very easy to get. You're going to need just 2 power supplies like this one, 5 volt each. It's exactly 5 volt power supply with this kind of jack, because the round jack, it's fitting exactly the one you put on the board, okay? And I was talking about the box, by the way. Let me see the box. Here it is. So here you have to pay attention. The box has to be exactly this size. That's exactly what I bought, okay? If it is in inches, 6.2 by 3.5 by 2.4. In the metric, 158 by 90 by 60, very easy to find everywhere, okay? So this is the kind of box you need to have. Again, the board is 7 by 10 centimeter. And then don't forget about the clamp, because this is the most important part of the project, the one where you catch the fan you need to measure about. And if I stop the power, okay, and I disconnect it until I open the box, I can quickly open the box to see what's inside, because if it is about the making, you have to know how to connect all these things together. Okay, let's find out. Ta-da! Here it is. So, yes, it's a lot of wiring. Here is the voltmeter. Here is the rotary switch. And all the connections coming here inside. Here are my 3 potentiometers. I have to still adjust a bit for the calibration. But now what I want to show to you is what you do for the purpose of troubleshooting, because your stuff has to work, okay? So here are the two jacks, okay, the 2 power jacks, okay, one for the industrial voltmeter and the other one for the electronics of the project. And if you take a look at this board here, okay, that's exactly the same size as the one I was showing you, 7 by 10 centimeter. So now, this is the board, so the voltmeter is over there, okay? If you give a power to the fan and you put it here on measurements, okay? So then you should be able to measure your speed. Don't need to do it right now. So by applying the power and putting it on, now the speed can be easily measured if you want to, okay? So you have a fan connected over there, or take a look here, the counting. Now we can check how the counter is operating. Remember about the reset? Now the reset is for 5 or 7 blades, and we have it for 7 blades. Take a look what happens here on the LEDs. 0 when all the LEDs are off, okay? So if I put it here on test, okay? So now we're not measuring the RPM, we're testing it. 1, 2, 3, 4. At the 5th pulse, it goes back to 0. So this is for 5 blades. Again, 1, 2, 3, 4, 5. Now we put it on 7 blades. It's gonna count 0 because all of them are off. Then 1, 2, 3, 4, 5, 6. At the 7th, it goes back to 0. So that's how you check that your counter is operating right, because depending on the number of blades, you can watch here in binary the counting. So again, 1, 2, 3, 4, 5, 6, 7. Or if you put it on 5 blades, 1, 2, 3, 4, and the 5th one, it sends you back to 0. But if you want to check the counter, the whole counter, to see the the whole possibilities of the counter, it has to count 16 counts from 0 to 15. So take a look. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15 is when all the 4 LEDs are on, and then at the next pulse is going to go back to 0. So that's how you know that your counter, which is over here, is working fine. And then you go back with the reset to your real situation and you choose the number of blades. So the reset 5 to 7. Now if you do the counting here, you're going to find out how many blades. 0, 1, 2, 3, 4, 5. So this is on 5 blades, as you can see. If you put it on 7, it's 0, 1, 2, 3, 4, 5, 6, 7. Okay? So that's how you can check the inside of it. Okay? So this is why I provided all the elements in order for you to be able not only to put some wires together, but to troubleshoot. And here is the last thing I want to discuss about is, if you give me a second, I'm going to find out the diagram, this one here. In this diagram, if I magnify it, okay, of course you're going to find it in the folder about the PCB. You take a look, for instance, at this one here. It says PB, push button. So on that terminal block right here, is not a terminal block, there are just 2 pins. Are these 2 pins over here. On these 2 pins, I connect, even if initially it had 3 pins, I just cut off one of them because I just bought terminals with 3 pins. So you connect it here only with the two pins remaining, okay? And you have your, take a look where it's going. It's going over here where it is the manual pulses, the push button, okay? The next one, if you take a look at the next one over here, this one has a notation J1. And what about J1? J comes from jumper, by the way. So for the J1, give me a second. I'm sending you over here. Take a look. Section 1 to J1. What does it mean? It means that this particular switch, I used all of them the same because I didn't want to change the switches, but this one is a double pole, double throw. So double pole, double throw is because it has 2 sections, each of them has 3 contacts. And on one section, you're going to mount J1. And where do you find J1? Let me just use this one over here because it should be a bit easier if I do. Is this one. Okay. So if we take a look here, the J1 is over here. And this one is right here. So this one goes on one section on the switch 1. And on the other section, if I take a look again on the map for the front mask, it goes to J4. So if I'm taking a look all around here to find where it is, you take a look, is J1 here, is J2 here, is J3 here, okay? So J4 is over here. So from this one, which is exactly over here, this one is going exactly on the second section of it, okay? That's how you identify after you place all the components. Very easy to do because I've just made the circuit for you here. And from each of the jumpers, which are 3-pin jumpers, you can find very easily, they are very cheap, okay? So let me show them to you again. Take a look. This is the 3-wire connector. And here are the jumpers, 3 pins, okay? The only ones with 4 pins, this one here, it's coming to the cable. This one, the cable going outside for my sensors. But again, you don't need to use this one. If you have a servo motor cable, you can only connect it over here, okay? So it's going to only need 3 wires. And the second one with 4, this is an older prototype, is not this one. On the real one is over here. The only one with 4 is this one, the one going to the rotary switch, because the rotary switch having 3 positions. There are 3 positions plus the common for the position, so you're making 4 of them. This is where you needed a 4 wire going over here. But again, you may not need this one. Don't complicate your life with it. You can omit to mount this one. And this is where you're going to find out from all around the board where each jumper goes, and to identify not only the components themselves, the resistors and the 3 transistors over here, but also the 3 integrated circuits. I put them on the sockets just in case. Is another thing for the troubleshooting. If anything goes wrong, you can remove them and place another one. Anyway, if you do this and you solder them right, I don't think you're going to have trouble for many years using the project to measure the RPM for your PC fans. Last thing I want to talk about for the printed board is, if I'm showing to you a printed board like this one and I magnify it, you're going to find here a couple of lines which are blue. Okay, what is about them? The blue lines are the wire jumpers you are going to put on the side of the components, because if the traces are black, they are going to be on the solder side. You just need a couple of, as you can see, there are not many, 1, 2, 3 here. Okay, so there are a couple of wires you have to place on the components board, and these ones on the drawings I'm publishing in the Google Drive, you are going to find these lines in blue. And this is why the holes here are not having a thickness, a real thickness, because these are making the passing between the side with the components versus the side with the solder. Okay, so very easy. Finally, there are not too many, there are just a couple of them, no big deal. And you're lucky because by having the circuit drawn, it's a bigger scale, because I want you to clearly see the components and so on. Okay, the board is actually fitting exactly on the 7 by 10 centimeter, and each 2 squares right here, they are the size of 2.54 millimeter, which is 1/10 of an inch. Okay, so very easy to watch. If you do this on a 7 by 10 centimeter, it's exactly the board. I used all the board from all the sides, so very easy to do. Okay, so remember, that's the final stage of the project, and this one you can take with you and measuring everywhere you want, the PC, fans, RPM, anytime you want. Thank you very much. See you next time. Bye-bye.